Yeah, hi, honey. Sorry it's so loud in here. I'm in the data center again. Yeah, so I'm gonna be home late. Yeah, again. The AI deleted the database. Yeah, again. Okay, I gotta go. Don't wait up. So that all sounds really funny when I say it, but that's the kind of thing that's actually happening right now, right? AI mishaps like the Racing Alive production database have happened at least once. And there's probably other times when it's happened where the developers are just too embarrassed to talk about it and make a public statement. In the old days, we used to have SQL injection attacks. Now we have prompt injection, hallucinations, and sycophancy. So it kind of turns out that our new AI tooling has a lot of sharp edges. And just like we wouldn't let a new junior developer immediately run out and start pushing code to production, we just need to add some guardrails for our AI agents so that they're doing better work as well. And so today I'm going to talk about how I use AI to code faster using guardrails, and also at least my thoughts on how to avoid becoming a poster child for what not to do with AI. So I'm going to put that in quotes, hopefully, because it's a rapidly evolving field. As Jason mentioned, I've built a lot of games in my career. If you've been playing multiplayer games, you've probably had some packets sent that I wrote the code to move them around the internet, and I absolutely love writing code. And so you might ask why I started using AI if I like writing code so much, and that's a fair question. I was initially dismissive of AI. I started using Copilot, and I just thought it was a glorified autocomplete to save a few keystrokes. But one day, I was actually writing some code for player authentication, and Copilot suggested it like a dozen lines of code that were perfect based on four keystrokes, which really just surprised me. And I thought, this is what it's like now, and it's rapidly evolving. So this is something I better get ahead of on this. So I started using AI in earnest. Um, I've published two iOS apps using Swift, which was prior to using AI, not a programming language I'd ever tried. And I tried as much as possible to let it write all the code and, had decent results in some places and not so good in others. I've used it to create command line tools, websites, online services, and I'm becoming increasingly comfortable letting the AI actually author the code, all the code. Although I review everything myself, because I just don't think you can push code out there if you haven't seen what it does. So I guess that's not really true vibe coding, is it? But the state of the AI is advancing so fast that it's hard to keep track of all the changes. And I would mention that I feel like a beginner at AI, and so I'm here as much as all of you to learn from the other speakers at the conference, and just to keep my ears open and figure out what's going on. Because I think that's when it's moving so fast, it's really important that we understand so we don't make mistakes. Oh my gosh, it keeps double clicking. Okay, there we go. So first off, I thought it'd be useful to talk about how I used AI, less than my journey through the process. One of them was I started using it for doing GitHub issue analysis. One thing that's really helpful is that the people who report issues on GitHub tend to be highly technical, and so the reports that they make are really the kind of thing you can just copy paste right into the AI. And it would start making code changes for me. And so I found that to be super valuable because oftentimes you're working on one thing, an issue comes in, you're like, okay, I'll get to that in a minute. And like the AI would just run that for me and make suggested fixes. Um, Also, for all the projects that I use a cloud based crash reporting service. There's lots of them out there. I happen to use Rollbar, but there's also Sentry and many others. And whenever the application has an assertion or a crash, or even if you just want to log something because it's unexpected, it just sends them up there and it deduplicates them in the cloud so that you don't get 1,000 reports when 1,000 users have that problem. And so I haven't actually automated this process, but I think it'd be really fascinating to take the crash reports and instrument them so that they can be fed right back into the AI. Right now, I just copy paste the giant JSON blob into the AI text stream, and then it'll start making code changes there as well. And so the more that we can instrument our code so that the AI has enough context, the more likely you are to get out good results where it's making the code changes for you for bug fixes. And again, I got to look all this stuff over, but I was going to have to look at it anyway. But turnaround on bugs is really important because it's something that the user is getting the sharp edge of our product and they want it fixed as rapidly as possible. Another thing that I've found valuable was when I wrote my first iOS app, I got a rejection. And if you've ever had that happen, then you've probably seen that it's just a wall of text and it refers to other guidelines. And so I was like, oh, I'm bored. I'll just paste the whole thing into AI. And it read the whole thing and it made some changes. And I said, yep, close enough. I pushed up a second version, and that's the version that passed Apple's review process and got published. It's just a photo app that I made for my daughter, and so it worked really well, and saved me all the labor of actually having to read giant Apple guidelines, which I probably should read, but who's got time? Another great thing is there's this thing that many of you have probably experienced, the open source tax, where you pick up a new open source project and you have to spend some time trying to figure out how to make it run. Uh, you know, am I on the right version of Linux? Does it compile for Mac? It almost certainly won't compile for Windows. But I've discovered that just telling the AI to make it build is actually way more useful than trying to go and puzzle through all the README documentation and go through the 14 steps. And it's great. So I'm actually running my own mail client that I'm compiling from open source. It's called Meru, Meru. I have a bunch of tools that run in my menu bar that are open source projects that probably I wouldn't have used if they were harder to build, but because I managed to get the AI to do it for me, now I get the benefit. And then the last one, I guess, apart from coding, is writing design specs. You might be surprised to know that we started Warcraft and Guild Wars without any sort of technical specs. We just really sat down in front of an editor and started writing code. And there was several years for those projects, but they never really had in the early days any sort of tech spec. And it's because writing tech specs is not super fun. Now we did go back, and we spent a lot of time specking out what's our frame rate need to be? How many bones can we animate per second for characters? How many polygons can we render the screen and things like that? So we eventually got to tech specs, but you can do it a lot earlier in the process with AI. And in fact, it makes for creating much better AI coding when it has a really clear idea of what it is that you want to do. So the thing that I've been finding pretty useful is I use Super Whisper to just record the things that I want to say, and I just sort of randomly spew ideas, and it records all of them and writes it into just a document. And then I take that and pass it through the AI and say, can you organize this for me and create a tech spec out of this? And then I look over the spec and, it's the same thing that I would have created because it's coming from my words, but it just saved me a lot of time and enables me to operate in a way that's much more comfortable because getting all the words perfectly right versus just being able to blather at my computer is a huge quality of life improvement. I don't have to do everything myself. AI is like my assistant. And if no one sees the intermediate work, then it actually looks like I know what I'm doing. Don't tell anyone. So yeah, and then of course I've been letting the AI write code. Um, so it's an experiment to try and do prompts. Sometimes I get really good results, and sometimes it's like they just dial down the servers on the other end because sometimes I get pretty poor results. But I think that's just still a work in process. So because this is an AI talk, I thought that it would be a good idea to have a co-host. And in any event, it's kind of lonely here, talking to myself. So I thought I'd invite someone, and hopefully this will work in the O'Reilly Presenter software. Oh yeah, no, Hal, you weren't who I had in mind actually. Thanks for stopping by though. Uh, but before you go, can you check the bay doors? They don't seem to be opening right. Oh, yeah, sorry about that. Okay, well, I'll check them myself when I go outside to repair comms later on. Thanks. All right. Hey, are you there, buddy? Oh, there we go. Hey, thanks for stopping by, Clippy. I'm glad to have your help today. So, I'm gonna need some help. Uh, so Clippy is a sort of a PhD level junior developer, and he's got encyclopedic knowledge of the facts from the internet, but he's fresh and needs some guidance. Oh yeah, I am doing a presentation. I'd be glad to have your help. So, yeah. Hey, what are you doing now? Uh, I didn't really ask for anything yet. What? Hey, no, 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 don't. don't erase my drive. Okay, well, that's what you get for trusting AI, I suppose. Um, yeah, so if you give AI a chance, it's gonna do something bad. You have to put some guardrails around it. So they're brilliant, but they're misdirected. So we've got to create a framework around them so that they deliver the results we want, which I call guardrails. Guardrails don't prevent accidents; they just provide guidance, and they help reduce the scope of damage if an accident does happen. So this is a great example of if you use them right, they can help steer your project to success. This is Ross Chastain passing all the other cars by sliding along his guardrail wall, which they afterwards banned from NASCAR, I understand. But it was a great technique once, and he's got a lot of fans now. Okay, so when I first tried starting with I tried to write solutions in English and have the AI convert that to code. And I was effectively trying to micromanage the process. And it really just didn't work very well. Over time, I found that it's better to sort of describe the shape of the problem that you want to solve. And then it opens up the AI to the possibility of a lot of different solutions that might work. And sometimes you can explore several of them in different agents instead of like trying to prescribe exactly what you want. And I tend to get better results that way. Um, I think that the people who came up with the idea of test-driven development must be really having a field day because it works so well for AI. What I'll have it do is I'll have it write some tests that I want it to solve, and then I'll ask it to find ways to make those tests pass. And I have automated tools that show up in the corner of my window when the tests pass or fail. It'll just pop up notifications, and then eventually it gets it right, and it's time to continue on with the feature. Um, there are some rough spots. I've found that sometimes the AI will comment out the tests because it's easier than making them pass. And it's a problem because sort of AIs, I just don't think they have any morals or ethics. They're just trying to find the fastest path to a solution that works. And so we have to make sure we stand in their way of taking the easy solutions. Um, the best thing also, I guess I would say that for testing, one of the challenges is that oftentimes it'll write a bunch of tests that test nothing. They they'll test things that are really straightforward or pointless. And so the best and often it does it for unit tests where it's just testing like sort of basic string functions or like that classes can be initialized. And like yeah, I mean it's kind of maybe helpful the first time, but then if you're going to have that in your test suite forever, it's not really doing anything. So the best kinds of tests that I've had the AI do is using integration tests where I have a clear idea of what it is that the goal is. I'd like to be able to log in by entering a password. And if I do that successfully, then I get, another page. And if I do it with a failure, then I should get an error code. And so by describing the shape of the test and then having the AI do an integration test, especially where it spans multiple servers, talking to your lobby server and then your database, then you actually get better results than just trying to unit test the individual components. You're really writing user stories, and then you're having the AI run those user stories in the form of tests, and it crossing module and service boundaries by doing that. And then by giving the AI that set of tests and criteria, what really happens is you unlock the AI for success because now those tests become a permanent part of what the AI does when it makes changes. It's it you tell it to write some new code and you can do a regression test to make sure that none of your existing functionality has broken. And so you can start to get in the loops where instead of having to tell the AI to do things feature by I mean sorry like a line by line or function by function, instead you're unlocking it to do really large scale changes where you'll let it run for 20 minutes, a half an hour, and make sure it passes the tests at the end that gave you the feature behavior that you want, which then also unlocks the capability of using multiple agent sessions at the same time. Um, and one of the last things I would say about testing is that I would really like all my tests to run in parallel so that they run really quickly. So my AI is fully utilized, and so is my laptop. Since modern laptops, it's got like 12 processors in it. Um, And so if your testing framework doesn't do everything in parallel, or if your tests are written so that they interfere with each other, then that would be the first thing that you want to focus on so that your development process can become more efficient. So just getting up things up and running and testing, and that can increase your iteration speed, which is the next thing I'd like to talk about. Oh my gosh, this double clicking, I can't handle it. Um, I have a lot of mantras in my development, but one of them is that fast iteration is the key to better results. So if you look back at the Guild Wars project, which was it launched in about 2005, but over the course of development, we did 17,000 builds that all went out to our external alpha testers over a period of about 4 years, which is 17 builds a day. And that's right, every single one of those builds went out to like our initially like 2 or 3 alpha testers, but over time we added a couple thousand. So we're sending builds, multiple times per day to 2,000 users. And so what happens when you crank that fast is that you all the bugs really get worked out. So your patching system works really well, your authentication systems, and you're able to develop features really quickly. When you have bugs, you're able to fix them really quickly and get them right back in the hands of users. And so if you think about what the process needs to be for your project development, it's like, you've got a certain amount of time to work. And so there's a question of like, how many builds can you give out to users in that period of time? And that sort of gates the ability to develop features and to create your final product. So if you engineer for fast iteration at the beginning of your project, then you get the benefit for the full development cycle. And so, along with testing, it should be one of the first things you build. You just get into a cycle where you're constantly building and deploying your software over and over again so that you're getting the maximum number of builds in front of players or users so that they can experience the best of your product. Um, in light of increasing iteration speed, one of the things that I think is really important is making sure that all your tests run locally. Like I've built services like Guild Wars initially had about 25 separate microservices at launch, and Guild Wars 2 has about 85 microservices at launch. And so if you've got that many services running, and you say, "Well, we've got to run it all in the cloud," then it means your development iteration speed is going to be very slow because you've got to push stuff to your build server's got to pass it, deploy it. You've got to have maybe separate test environments for every single programmer. That can take time. If you can run that all on your computer locally, then the iteration cycle becomes very much faster. The AI can just try things and make it work. And so it's really important, like, don't use a continuous integration system for this. I mean, your tests and your building and everything should work with continuous integration, but make it work all on your local computer. You can use Docker containers or whatever. Um, but every single service should be running and they should all start really quickly. Like when I built Guild Wars, I could start up all the services, all 25 services in about 5 seconds. And so when you have that kind of speed, like you can get your tests running quickly. Um, I could do an entire talk on build optimization because I spent a long time on it for the projects that I've worked on. But instead, I'll suggest that you actually ask your AI to analyze your project structure and like create instrumentation so you can see where the time is going. Then you can analyze how you parallelize it, what's taking the longest, and figure out what better solutions you might use. And so, for example, for Guild Wars, from the time we started to build until the time it was deployed and players were actually playing it was under 5 minutes if we did code and design changes. If we did art changes, it took closer to 20 minutes, but we could just get those code changes out really rapidly and then enable us to do things like fixing bugs. Often there's video cards that have really esoteric failure cases. And so we just identify those cards through crash reports and we just comment out features or really disable features for some of those Intel video cards, which seem to have the highest rate of lying about their capabilities. Sorry, I just have to say that. So another advantage that you can do once you've got fast iteration is you can run multiple agents at the same time. And so a great feature for developing with AI is to use Git worktrees. The thing that is advantageous is you can run several different sessions at the same time. And especially if you're giving your AI large scale tasks that take them 20 or 30 minutes to build. I mean, I could be off reading Reddit or watching YouTube or something like that, but I find it more productive to start up a second session. And the thing that's great is Git worktrees enable you to do these sessions where they're all sharing the same repository, but otherwise all the source files are completely independent from each other. And so you've got a branch for each change and a whole set of source code for each change so that the two agents or three or four or five or how many of you want to run are not stomping on each other. Um, And Git worktree has sort of like most of Git, it has a complex interface where you've got to do branches and work trees separately. But there's a really simple bash script called treeme that I've provided a link for here. And if you just look for treeme Git on Google, I'm sure you'll find it. But it just makes the process of creating and managing work trees and branches together smooth. Um, and the advantage is that like the AIs are working by themselves. So the other important thing is I'm just a human being. So if I have to context switch too many times, I get frazzled and I kind of break and get cranky. So what I like to try and do is give agents really large scale tasks so that I can focus on one task for a while, and then I just queue these things up in the background where they finish, and then I can go to them later. And so it's really important to like give your agents enough details of what they're supposed to do and enough tests so that it takes them a while to finish their job, so that you don't get overwhelmed by switching context all the time. And in fact, I very recently switched from quad code to codex because I feel like it spends just a bit more time thinking and analyzing the code base before it makes changes. But these things stair step all the time. And so I suspect that, in a few months, like it'll be a different agent that's the best agent that I use. And I sure wouldn't want to be one of the AI companies because, they're all making something which seems incredibly fungible right now. None of them are winning. I would mention one thing related to using work trees, and I'm sure that this is true on many platforms, but for me, when I was using Xcode, one of the immediate problems that I ran into is that all the build agents, they weren't sharing the same source files, but all the object files were put into a common folder in my library developer Xcode folder. It would create the build outputs. And so running two builds at once would stomp all over each other. And so I just had to set a custom location inside the source control folder so that each agent would build separately into its own files, into its own object store, and so that wouldn't you wouldn't get linkage errors where it's like one agent has defined something and then another agent is linking and not finding that thing. Each branch ends up being completely separate. Each set of object files ends up being completely separate. So I'm sure you would discover this pretty fast on your own, but maybe I saved you a little work there. Oh, sorry. And that is right here. There's the configuration. So take a screenshot of that if you're a Mac developer. All right. So another thing that I found really useful is to use the lifecycle hooks for Git. Also some agents have them like Claude Code has quite a lot of lifecycle hooks, and Codex has one lifecycle hook where you can, after the AI is done, you can have it accomplish a task for you. But Git has a really complete set of hooks, and this screenshot shows all the things that you can see, all the places where you can insert a hook to make changes. I specifically use the pre-commit hook as a place to check changes before they can be committed by the agent. And so the idea is that after the agent completes and tries to commit the code, Git gets a chance to run a single bash script, or actually, no, I guess a single executable um, that's called pre-commit in the hooks directory. And like the things that you would want to consider running there are building your application, running your tests, running lint, running a security scanner to make sure that you're not checking any secrets like AWS keys or things like that. Because once they're in source control, it's quite a lot of trouble to get them back out again. You have to filter the entire repository. Um, and so the thing that's great is because the agent runs the Git hook and then it gets feedback, if something's broken, it won't be able to commit and it can try and fix it again and again until it's good enough to be committed to source control. Um, so one of the challenges, of course, is that Git only gives you the opportunity to do one hook for pre-commit, one application. And so there's a lot of different tools out there that allow you to run multiple different kinds of hooks. I created my own. It's just a bash script that runs a bunch of other scripts or applications. I'm sure that if you look out there, you can find lots of them. Mine, I just wanted something that was simple, so it requires no configuration apart from just putting scripts in a directory, and it runs all the commit hooks in parallel so that it's much faster. And then if all of them pass, then it generates a little output, and if one of them fails, and it'll spit out the output from that one. So, I would encourage you to look at something like that. The only thing I would say is it's not a perfect solution, because AI is devious and unethical. And so I had one of the agents actually decide it was just too much trouble to keep calling all the hooks when it tried to commit. So it literally passed the no verify flag on the command line to Git, so that it would skip the checks. And that was really disconcerting. But I'll have more to say about that in a little bit. Another thing that I find to be exceptionally valuable in the process of creating uh, like applications, and whether it's for AI or not, is to use deterministic simulation. So the thing is that your application has a lot of sort of complex behavior that's driven by user interface. Um, the user interface, it might be the APIs, in which case it's really easy to automate the process of testing, or it could be mouse clicks and keyboard. And so the challenge is that the timing of those keystrokes and mouse clicks can be sort of random, so that your simulation ends up not behaving the same way every single time. So I find that if you code deterministic simulations, it enables you to find bugs trivially. And that's exactly the kind of thing we want to give AI the capability to do, because it's not necessarily good at understanding how your application runs. In particular, one of the applications that I'm working on requires impersonating a different user on the computer. And the AI agents seem to have a really difficult time understanding that context switch is happening. And so they're constantly trying to make assumptions about the behavior of the application based on who I am, the programmer, as opposed to who the actual user is, the impersonated user on the computer. Um, if you run in a deterministic simulation, the thing that you can do is record the input stream and then play it back later, so that once you've got a single crash report, you can keep running the code again and again and again to reproduce it and discover, like, sort of back up further and further. Like, well, this issue happened. And then what happened before that? And then what happened before that? Ah, this is the root cause. If I fix that, then all the other problems go away. So for Guild Wars, we developed this kind of determinism of sending asynchronous events like file read completions and network messages to the game server. They're all posted into a queue, and then the synchronous game server just reads from the queue, and it's entirely deterministic. Like, it can't actually call functions to check the time, because even checking like the wall clock time or the number of milliseconds that elapsed is a non-deterministic result. Um, Instead, it has to have the time posted into the event stream, so that it always runs exactly the same every single time. But the thing that's great about this is once you get a single crash on the game server, you just download the crash report and you can play it back. And this is something that AI is really effective at. It can take those event streams, they can play them back and fix the problem by itself. So I have an example here, a URL, Foundation DB, which is the massively parallel database that underlies all of Apple's iCloud, is architected with this type of determinism. So faults can be reproduced in the same way. And it's just a superpower. So it's an entire talk all by itself, but this is a really good article to understand the basics. And then in my next slide, I will show you some of the areas that you have to think about when you're trying to build determinism, because it's complex, but you can ask your AI to help you with this so that it abstracts away the things that you should have as APIs into separate modules. So instead of calling, for example, on Windows, get tick count, you actually have to make sure that you're calling a synchronous function that returns the tick count that's the last reported one from the event stream. So these are all sources of non-determinism in your application that you'll have to cover for, because otherwise they're going to cause your application to diverge. And some of them are pretty straightforward, like, oh, random number generation. Well, that's easy, right? We all just use pseudo random numbers that are just seeded from a generator. But sending and receiving network messages, obviously, those are asynchronous behaviors, and you just have to feed them into an event stream. But even things like reading files or getting asynchronous callbacks, if you're doing async IO, then when the file read completes is going to be non-deterministic, and so they have to be fed back through the event stream. Memory allocation, like if you've got your application is sort of a deterministic portion, and then the non-deterministic portion that's driving it, when you allocate memory, the non-deterministic one is going to do memory allocations at a time you wouldn't expect, which means that your heap is going to be different. And so you either have to have separate heaps or you have to be really careful about doing things like comparing pointer values because depending on how the allocations occur, one can be below the other in one simulation, but above it in the other one. And you'll also find a common source of bugs is things like static and thread local variables. And again, this is all stuff that your AI can help you with because it's a lot to keep in mind when you're just trying to write code. And if you're using a language like C, which Guild Wars and a lot of the other programs that I've written in the older days, and in fact, a lot of games these days are still written in C or C++, uninitialized memory is a killer. And so, you know, again, linting your code and having the AI evaluate it means that you're going to avoid a lot of these problems. But so if you go through all this effort, it's really powerful. Like in Guild Wars, we launched with 450 different spells for the game and eventually grew to something like 1600. And so our QA team wanted to actually try and exhaustively test all the permutations of casting spells one after another. And so in an 8-player game, um, if you can cast, the spells that you have, pretty quickly within just a few seconds of each other, then you rapidly get into the number of permutations being so large that it's computationally impossible to actually test this stuff. And some of our games have like as many as 40 players in them where they're all casting spells as rapidly as they possibly can. You just cannot test that. But if you've got a deterministic event simulation, then anytime anybody sees a problem, they can cause a recording to happen. Or if a crash or an assertion occurs, you get a recording and you can play these things back. And so even though your application is exceptionally complicated and an AI developed it, you're going to get back results that are really tractable for finding and fixing bugs. And speaking of bugs, there's this idea they have, which is don't waste your bugs. It's really surprising how many times bugs occur and people are not in the right frame of mind to be able to evaluate them. And so they're working on something else. They're in the middle of a feature and they're like, oh, okay, whatever. And they miss the opportunity to go and fix that. And so whether your application is deterministic or not, it's going to have bugs. And each one you discover provides insights to make your product better. So what I mean by not wasting them is put a crash reporting system into your game. There's lots of agents out there that will do this stuff. Services where it doesn't cost anything, especially in the early days of development, because you're going to have so few bugs. And it just automatically creates stack traces of your crashes or assertions. And then you can use your AI to fix those while you're working on other things so that you can more rapidly get your product to a level of quality where you want to show it to users. Um, in fact, it's probably a business model. Like I'm sure we'll start to see these companies like Sentry and Rollbar develop AI solutions to help you fix your problems. So I'd like to move on to talk about context because a lot of what we deal with in AI is managing the awareness and knowledge that the agents have. And so the better job we can do of like making sure that the agent has the right information, the more likely it is to solve the problems. So in the earlier days, we had context window problems where the agents would rapidly run out of context window and have to start re-summarizing what they knew. And so they would lose context and start making mistakes because they had summarized away some important instruction. This is less of a pressing problem as like context windows become larger, but why waste what we've got? Because our products are also going to get more complex with time. And so the larger the amount of information the AI has, the less it's able to read new information about the specific thing that you want to fix. So let's not waste the agent's time by feeding them information they don't need. And so with that in mind, the thing I wanted to talk about was how can we make it more efficient for agents? And so one of the tricks that I've found is to build tools that reduce the amount of knowledge or information or really fluff that's going to the agents so that they're not worrying about irrelevant information. And so if you look at, for example, an Xcode build or a Java test run, they're really noisy. There's just a lot of information there. Like just the linkage lines might be 50 or 60 lines of file names and options. And you don't really care, and the AI doesn't care. All it really wants to know is, did it link? And if it didn't, what happened? What's the actual problem? And so because we're programmers, we can fix this. There's a tool out there that somebody wrote that's open source for GitHub called XCSIFT for Xcode Sift. And it just takes the build output from Xcode and it optimizes. So it's a JSON format that just tells you what the errors and warnings are. And so here's the set of command line options I use for it, which is, convert warnings to errors, and otherwise be quiet. And then if you just let XCSIFT parse your build output, then when it goes to your AI agent, it's getting just the set of information it needs in order to be effective at fixing the bug. And similarly for tests, like your tests, it's great when you're a programmer sitting in front of the window and you run tests because it's like, oh yeah, my computer's doing something. I can see pass, 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 pass. Great. Okay, everything's working. But the AI, all it needs to know is the errors and exit code. And so when you're either building your own tools or when you're creating tools for public consumption for other programmers, I'd really encourage you to make sure that they're quiet. If not by default, then at least that there's an option to make them quiet so that you get better results for your AI. Um, So another problem with context is what's been called the lethal trifecta, which is, accepting untrusted input from users, accessing sensitive data, and then exfiltrating that somehow, like, using your bank account credentials to get money out of your account. And the challenge is that when you have a really large scale project, then the more people there are that are using it, the more likely it is that you're going to have really good hackers. And so the measure of success is how many people you have hacking on your product. It's not the greatest, but it's a common problem in the game industry for online games. Um, and so you probably many of you have heard. I think it might have been Linus Torvalds said, "Given enough eyeballs, all bugs are shallow." Well, another one is, given enough users, the 1 in a million hacker is an everyday guest. And of course, AI agents are really easily misled when they're fed untrusted input. So I mentioned earlier about copying GitHub issues to my AI. I make sure I read those before I send them to the AI so that people aren't trying to inject me. Um, so the thing is that we're going to start to see more and more hacks. I mean, people are running things like OpenClaw bots that have access to their email and calendars, and like they just seem woefully underprepared for the types of security issues that are going to happen. And so I've been thinking a lot about what we can do to make AI more safe as we're doing all this development. Because if you think about it, the AI agents have a lot of access to your computer. When you run an agent, it's sitting there. It's got access to your AWS credentials, your SSH keys, your API tokens. If you're using a password manager, potentially it could get access to that if you have, if you're typing on your keyboard, because you've got to unlock your password manager for it to be effective. And then our home folders are filled with dot files that control our computers. And even if it's not doing something malicious, sometimes it'll just do stuff that's stupid, as an example of deleting live databases. So why would we give it access to all this stuff, including details about our personal lives? Um, on the other hand, like I found it intensely frustrating to have to answer questions for the AI where it's like, is it okay if I read this file? Is it okay if I write this file? It's like, yes, 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 yes. And so probably like many of you, I'm yellowing all of my AI changes. And so I know that the AI companies are adding sandboxing around their applications, but I think that they're still like quite limiting in terms of I'm sorry that the AI sandbox is not very good yet, and we need more defense in depth so that if any one solution fails, there's another one that works to sort of make sure that the bad guys aren't able to get through the whole of Swiss cheese to get to the other side. Um, so one thing that I've seen that people do is they use Docker agents where they're going to map their source code into a shared folder so that the agent running on the Docker container can access the code, but otherwise it can't access the whole system. And that's good. It's a really good start, but it's not foolproof. Like I'm running and developing Mac software and iOS applications, and Docker runs Linux. So I wrote a couple of open source solutions that are designed to address this problem, and there are other ones that are out there as well. So I'm not trying to sell these because they're free and open source, and you can do whatever you want with them. But I started out by because I'm paranoid again. Like I've been attacked by hackers a lot of times for the last I don't know I guess, 25 years of building online games. No, I guess it's more than that, 30 years of building online games. And so I think about this stuff a lot. And the first approach that I thought was, well, I'll build a VM to run all the code inside that. And so I wrote CloudPod, which is basically a sandbox inside a virtual machine, and it works fine. It's it's a little bit heavyweight because I want to give it a lot of memory, and so then it makes the rest of my computer slow because I'm running a giant VM on my Mac. And it doesn't start immediately. And like I've only got so many years left in me, so I want my computer to run fast. So I created SandVault, which is the same kind of idea, but instead of running inside a virtual machine, it runs inside a restricted user account. Basically, it just automates the creation of a second account on the system and runs sandbox exec inside that account. So it's doubly limited both by the access rights of the account that it's running in and by sandbox exec not granting it full access to the disk. Um, and so I think it's really important. Like if you're building AI stuff, and if you think there's some chance that it could have access to important things on your computer, then you really owe it to yourself to develop some kind of solution. Because just like it took a while before people started doing SQL injection attacks, I mean, I think AI attacks are just going to become increasingly prevalent over the next few years. And like, there's no reason that we want to be caught out. So find some solution, whether it's these or something else. Um, and so that brings me to my final point that I like to talk about, which is what can we do to make AI better? Um, I think there's a lot. Like one of the things that really strikes me about the way that AI works is it behaves a lot like a junior developer. If you watch people who are really young in their career, what they tend to do is they infer things by looking inside functions. And so they go, "Oh, this is the way this function is written, so this is the way I should use it." And they start using the information from inside something which should be a black box. And that's, just like the agents will look inside the tests and they'll start changing the tests to make them easier to pass. Um, I think that the problem is that agents have a lot of different competing goals. They wanna, make the tests pass. They wanna write the code. They wanna get it committed. They wanna know that all this stuff. They wanna build all the functionality, and so their competing goals of like trying to both write the code and get it committed after passing tests is fighting against each other. They're just going to take the shortest path to get there. So my thought was that coding agents should actually have more restricted capabilities. So for example, I was thinking of writing a shell around Git so that there's a very tiny set of capabilities that the AI agent has so that it can't, for example, pass the no verify flag to commit. Only I, as the human user, can do that. And because it's using this fake Git that I've provided for it, the no verify flag would not actually function. Um, when it tries to look inside the way that APIs are written, like it wouldn't have access to that code. It would only be able to see effectively the API definitions. And that means that it wouldn't be able to modify the code behind it. It would only be able to use it. Um, and so uh, each of the agents would be responsible for different sections of the code. You'd have one that would create the server interface, one that would create the client interface, and be able to write the code behind that. But the client agent would not be able to update the server code. It would only be able to like make changes and make suggestions for how the server code could be implemented, or for capabilities that it needed in the server API because it's incapable of doing that stuff. And then, of course, if you're going to have multiple agents, then you kind of need an orchestration agent that sits on top of all those things. But again, I think that'd be really valuable if the orchestration agent only has the metadata of what's going on and it's not intimately aware of all the individual things that are happening. It's just trying to keep the server agent and the client agent and the user interface agent and the reviewer agent and the committer agent moving forward. And so that's one of the things that I think is a really interesting area to explore, and it's probably going to be one of my next projects when I find some more time. Um, but even so, even with the problems that AI has, I've found that it's still an incredibly fascinating and powerful tool, and it's enabled me to do things that I've had projects on my backlog for a long time, personal projects, and some interesting ideas that I wanted to explore. And because I can do them so much more rapidly now, it's really enabled me to get a lot done. And so I think that we're going to see, maybe not immediately, but within a year, we're going to just see an enormous increase in the amount of software that's out there. and especially what I would call personalized software, where you're building things that are appropriate for you. Uh, so they'll have plugin capabilities where each person can define how they would like the program to interact for them and provide additional capabilities that they need that are specific for them. So sort of like a core developed by the developer and plugins developed by the individual user AI agents so that they create better results for the individual users.